Today, we will be talking about Distributed Test Manager, or DTM for short. DTM is a Windows application that can simulate SCADA communications across an entire substation or at a device level. It can also be used to perform manual or automated tests to confirm the behavior of these devices. Now let's take a look at where we expect DTM to be used in the engineering process. DTM can be used in the conceptual and design phase to simulate devices that you do not have or devices that are not fully implemented yet. During these phases, we expect devices to be iterated on frequently, so updating DTM simulation easily was always a priority for us. During this phase, manual and automated tests can be created to ensure your configuration of your devices will behave properly. Next, during the factory acceptance testing, you can use that same simulation you created in the previous phase to test your physical devices as you get them. Each device can be inserted into the environment where the simulated counterpart could be disabled. This allows you to run those automated tests again with each devices individually before integrating them into your physical system as a whole. And while DTM does not take a large role in the commissioning and maintenance phases, we do expect substation technicians to be trained on the simulations used in the previous steps in order to have a deeper understanding of the physical substation, and to be trained on what to do in situations you may not want to put the actual substation into. The last thing I want to talk about before we get on to the actual application is all of the parts that make DTM tick. DTM stands for Distributed Test Manager, and for that distributed nature to work, we had to break it up into multiple different parts. The part everyone's most familiar with is DTM Admin. That is where you can add devices, scripts, controls, displays, everything that you have access to within DTM. But behind the scenes, DTM Admin is communicating with DT Control, DT Manager, and DT Host. DT Control will launch as soon as you launch DTM Admin and will try to launch everything else as well. This should all be handled behind the scenes, so you won't have to worry about it too much. But if you are planning on doing a distributed nature, you must understand that DT Control must also be run on all of your other slave machines. Only one DTM control needs to be licensed for your product to work. Just make sure it is set up as the DT master. DT hosts are where all of your protocol devices are going to reside. All of the CPU and RAM and resources needed for the device will be allocated to DT hosts as well. So this is our DTM Administrator GUI. On the left-hand side, we have the workspace. This is where you'll add all of your devices, your scripts, your controls, and everything you need to run your tests. In the middle here, this is where you'll see your models or your databases, your displays, your test managers, or anything else. Currently, since we have an empty workspace, the Getting Started page is here. And then at the bottom, we have various tools, depending on your uses, and this is all completely configurable on what you want to display when looking at your workspace. Currently, we have the output down here, just keeping us up to date on what is going on. Let's start by adding devices to this workspace. Of course, you could go in and load any of our popular workspaces or our sample workspaces, of which we have for each protocol, but I feel like if we start from scratch and show you how to build them up individually, that will be the best way to learn. So you just go over here to your workspace and then right click and then do add. And once you do add, you can add a few things here. Of course, you can add all the protocol devices, including DNP3, ICCP or TASI2, 6870-5-101 and 104, 61850, and Modbus. You can also add folders, which is used for organization and also gives you some hierarchical powers later. You can also add test managers, displays, JavaScripts, and many other things from here. So I'll go ahead and add a folder. I'll name this DNP3 Outstations. You can also come in here and add another folder, let's say, and we'll do 61850 servers. Now, you can organize this stuff however you'd like, whether it be from geographical location, functional, behavioral, however you want. I just simply chose a protocol. So we'll go over how to add each of these, as they are basically the only two ways to add devices. First, we have the DNP3 outstation. Now I can right click on the folder and do DNP outstations. and it will walk you through a wizard to create these devices. The first thing in the wizard will talk about where you want to host this device. Currently I'm sitting at Matt's ThinkPad, but if you had the distributed nature of DTM, if you click this drop down, you would be able to see your other machines here. This is effectively for what resources the simulated device has access to, meaning CPU, RAM, network adapters, things like that. I'm going to leave it on Matt's ThinkPad for now. The next thing you can configure is your TCP/IP or your serial information. You have access to any of the IP addresses on the computer in the previously determined tab. And the remote address is where your physical device will be, or another simulated device that you'll connect up to. Of course, you can do serial as well. The next thing we'll look at is the Sessions tab. This is going to be more specific to the protocol you selected. And so for DNP3, we have link layer addressing, source and destination, unsolicited messages, or secure authentication. The database tab is next. This will allow you to configure all of your data points for your database. You can go into the individuals and change any sort of configuration on the individual points. You can reset all of them and create your own kind of custom database however you need. It's totally configurable. If there is a database that you're going to be using frequently and you don't want to have to recreate each time, you can then export that database to CSV and bring it back in. The Advanced tab is where you'll find everything you did not find in the previous 4 tabs. The previous 4 tabs will get you done 80% of the time, maybe 90%. When you're looking for something specific, such as timeouts or buffer sizes or things along those lines, if you're getting a warning in the protocol analyzer that's mentioning a misconfiguration, you might want to come in here and check to make sure that these are the appropriate and expected values. Of course, after that, you can go to multiple devices. If you only need to create one, you can just click OK and you're good to go. But if you need to create multiple, you can select this radio button and increase or decrease the amount that you wish to add. Now, I'm going to go ahead and just create one, and it will pop up over here, and you can see that now it is simulating. The one thing I always try to check for right off the bat is the indicator. There is a connection indicator next to the device letting you know if the device is connected or disconnected. In this case, it is disconnected because I actually don't have a physical DNP3 master plugged in, nor am I simulating one. Now, let's take a look at that same process, but for 61850. You can just right-click, add 61850 server, and what you'll notice is a lot of these tabs are missing. And the reason they're missing is because all of the configuration for 61850 can be supplied through an SCL file. So to select your SCL file, you can just go here and click Select SCL File. Anything already in DTM will be displayed. I don't have anything yet, so you could go to Import Configuration, or I'm just going to grab a sample configuration. I'm going to be selecting our breaker.icd and hitting Open. Now DTM is going to offer to monitor this. And the reason we want to do that is because we know that SCL files can be iterative and updated frequently. And instead of having to trash your DTM workspace or go through a process of updating it every time you get a new SCL file, we allow DTM to have the option to monitor that file. That way, if any change happens over a nightly build or whatnot, you can just go in, drag that new file over your old file, and the next time you launch DTM, it'll say, you had 6 devices based on this SCL file. Do you want me to auto-update them for you? And they'll go ahead and update to the newest revision. I'm going to say no because I know this is a sample file and will not be updated, but this is something to consider if you are going through the design process. After that, you can just hit OK to select that, and we'll see that the configuration for this device has already been built in. It's going to go ahead and select the breaker.icd I provided, the IED to load. This is just an ICD, so there's only one in there currently, and it's just going to select the only access point. Now, since this is a sample file, we didn't put a specific IP address in it, we just used 127.0.0.1. That way, anybody who had our DTM tool and got this file would be able to simulate this device. Of course, you can click the drop down and change it to whatever you would like, allowing you to communicate on that IP address, or if you have your own SCL file, it'll bring the IP address in from that SCL file. You can even come in here and type in whatever IP address you'd like, and even though it turns up red as I don't have that IP address, you can come in and click Assign IP Addresses. Provide a subnet mask. And it will give you a warning and say, hey, we're actually going to go out and reconfigure your network adapter. This can be important because if you're sitting on a network and you reconfigure your network adapter to have an IP address something else does, that can cause an IP conflict. So make sure you know that what you're doing is safe, and this is just a warning for that. Now, when DTM reconfigures your network adapter, it does it constructively, not destructively, meaning you will keep all the IP addresses you already have, but it will switch you from a dynamic IP address to a static one. So if I click OK, it'll go ahead and attempt to try to ping that IP address, and nothing has responded. You can go ahead and select whichever adapter you would like to edit. I'll do my Ethernet cable here, and then you just click Assign, and it will go ahead and add that IP address statically to that network adapter. You'll see it turn green and we're good to go. If you're using Goose or Routable Goose, you can select that here. So I'll go ahead and use my Ethernet as well. And if you are using sampled values, that's in the advanced. Scroll down a little bit and we have our sampled values adapter. Now, if you are using sampled values, make sure you understand that it takes up a decent amount of bandwidth of routers and switches in order to do sampled values. So you might want to be on a testing network or something like that. Now, if I just click OK, we'll go ahead and simulate that device. Now, what if you provided a SCL file that had multiple devices in it? Well, you can right-click, add 61850 servers again, and instead of selecting an ICD file like I did previously, I'm going to import the SCD file we looked at in the Navigator video. If I click OK and open this, again, I'm not going to monitor it. I'll hit OK. Now we'll see that it's already started trying to configure this. But if you go into IED to load, you'll see there are so many more IEDs that you can add. This way, if you select a different one, it'll go ahead and reconfigure to be that device. Though, if there are 15, 20, or more devices in here, you may not want to do them all individually, as this might take a little while. So we added one more functionality to speed up importing entire substations of devices. So I'm going to cancel this and show you that method. You just go to File, Import IEDs from SCD. From here you select your SCD file and click OK. And it will give you the information of all the devices in that SCD file. Now you can see that I already have all of the IP addresses for this SCD file, but if I didn't, just like before, you can select any of the IP addresses you don't have and click Assign IP address. We have three different modes that this functions in. We have SCL file restrict, that means this entire table is filled out strictly based on what's in the SCL file. We have user defined, which allows you to go in and make changes to things. That way you can run your simulation a little bit more flexibly. Or if you just want to do it very quickly and not worried about IP addresses or networking at all, you can do loopback addressing, and that'll just give everything in an IP address on your loopback adapter. Since I already have all of the IP addresses, I'll just do SCL file restrict, and then I will select all of these by holding shift and clicking the bottom, or you can just click import all, and then you can just drag and drop these devices into the workspace. And sure enough, we're going to go ahead and get all of the devices being simulated and brought up into our workspace. So that is how you can simulate devices in DTM. The next thing I want to go over in DTM is how to actually simulate data changes on your simulated servers. One of the best ways to see this is through an interaction with a client. So I'm going to go ahead and add another folder and name it 61850 client. And I could have just put this on the workspace, but I like to keep things organized. So I'm going to go ahead and right click and add a 61850 client to that. And I could use Discovery and connect up to any of the IEDs that I'm simulating, or like I did with the server, I can provide the ICD file. Once I add that in there, I have to remember that I made a customization to the configuration, so I should do the same to the client. It was on the 1523 subnet, and the server address is also going to be this. So if I click OK now, we will see that the device here is turned green. This is the client and has connected up to the Bay controller device. Now I have a communication going. in a normal situation, one of these would be the physical device under test, but for the sake of training on DTM, it's best to show both sides of the communication. But now that I have them connected, I can do things from the client like a command to read, write, or control. The reason I wanted to get this in during the data change section is because I want to enable report control blocks so I can actually see that data coming across the line. So I could come down here to report control blocks, and I'm just going to go ahead and enable by selecting this radio button and enabling all of them. Now I could click OK, and that would put the node on the workspace, allowing me to interact with enabling these anytime I want to, or I could just execute this once. I could also set this up on a scheduler, so that way anytime I load the workspace, this client will automatically, after being instanced, try to enable these report control blocks. So I'm going to hit on connect, and I'm going to hit OK. And then if I wanted to run it manually, I could right click here and do execute command. So now anytime the data changes within that bay controller device, that bay controller should, if it is the data attributes changing are part of a report control block, package that all up into a report and send that over to the client. Let's see that in action. So to do that, I'm going to open up the bay controller and right click and do show model. Now 61850 is different than a lot of the other protocols in DTM, as it is laid out in a model view rather than a flat database view. A flat database view may look something like this. If I do show model, if I do show database, it's all of the points, you've got your path, and you've got your values. Whereas the model has things more organized. So if I wanted to see the measurement values, I could go to the MMXU, that stands for measurement. If I wanted to see, say, the voltage, I could go into the volts. We've got phase A, B, and C, open that up. And then we've got the range, the quality, the time, all of the kind of metadata associated with this. But of course I could go down to the magnitude. Now, I've got this open in the server, and so I should be able to change this. The server in the real world would be hooked up to some sort of electrical equipment, and it would be monitoring what the actual values are. DTM doesn't hook up to currents on lines or things like that by default, so you can actually just come in here and manually change this. So I could double click and change this to 100 and click off, and sure enough, it'll update. Now, the question is will that actually generate a report? So if I go up to LLN0 and open this up, we can look into the data sets, and sure enough, there is a measurement data set, and it does include some voltages and amps. There's also another measurement, and there we go. There's my phase voltage. So we do have a measure data set. Let's see where that's used. I go into the report control blocks, and the way we've named it is buffered report control block measurements 001. And if I open that up, it is using the data set mesh. So theoretically, once I change this value here to 100, the value should have issued out a report. So I can go down here to the report section and click on that. I'll get a little bit more real estate here, and we'll see that when the enabled report control block came across, all of the reports were sent out, but only one of them on the mesh has changed, and that was because of a data change. And if I click on that and look over at it, let me grab this real fast, we'll see that that 100 came across the line. And now if I come in here and change it to 200, another report will come across, and we'll see that it's 200. So you could go in and manually change things just by hand, whether it's breaker positions, double bits, analogs with like voltages or currents, but there's a lot of other ways that you can change data. The next simplistic way of doing it is just to come in here and right click and do data changes, and then doing auto data changes. Auto data changes by default will go out and look for every data attribute inside of a report control block or inside of a data set that can then eventually be used in a report control block or goose control block. So it's found 24 total data attributes. Now, you can, drag these in manually, you can remove the ones you don't want, you can configure this however you'd like. You can insert, just your MXs, your STs, but for the sake of this demo, I'm just going to say every 2 seconds, let's change every value that could possibly generate a report. So I'll just click OK now, and we'll see that this little node has been set up here. I'm going to clear out my report window, and I'm just going to say change once. So it changed the value here, which did generate a report. But if I take a look at the report, we'll see there's a lot more values in here as there's more stuff being reported. I could also right-click and do Start Auto Data Changes. And now every 2 seconds, we should see a new report being generated because all the values on those points are changing, which is generating the report. Now I can stop this. And to show off a little bit of power with the folders, you'll see I have a bunch of different devices in here, and it would be a lot of work to create an auto data change on each of them. So if you go up to the folder level here that we added in the previous step, and do data changes, and do add auto data change, it'll say there are 20 different devices in this. Do you want to do the default database for them? I'll say yes. And then it'll actually go and find every data attribute across every single device. So now if I set this to say every 2 seconds, and I'll give it a custom name, and hit OK. We'll see that we have this auto data change all now on that device, but we'll also have one at the folder level. So each of the devices will have a reference to the one in the folder. If you enable the one on the specific device, only that device's points will change. But if you change it on the folder, if I start doing start data change now, it'll go out and find all the data attributes across all of the devices. You'll see little indicators have popped up next to them letting you know that there are data changes happening. And sure enough, the reports are updating and the values are updating as well. I'll go ahead and stop this for now and show another way. So we've got manual changing, which allows you to be as precise as you want, but it's one at a time and it's a little bit slow to do on a mass level. Then we've got auto data changes, and that auto data changes allows you to change a lot of things really quickly, but only through a set parameter such as on, off, or ramping, or sine waves, or maybe layering noise or something on top of it. The next level you can do would be if I right click and do data changes and add a CSV file. The CSV file will indicate states and values, and then in each state you'll be able to, it'll set all the points to those values. And let me show you what that actually looks like to give a better example. So if I do import CSV file and bring in this breaker and hit OK, it'll ask, do we want to do it playback? Do we want to do it one step at a time? And what the configurations? Do we want to restart it once it finishes? Do you want to go twice as fast as it was recorded? You've got all these configuration options in here, but for now I'm just going to run it as default. And I'm just going to open up this CSV file, just so that way you guys can see exactly what's going on inside of it. So the CSV file is brought up in kind of this sheet here, and I will open it all the way. And what you'll see is we have paths to all of the points that we want to change within that breaker.icd file, the simulated device. And then we have 4 different states here. We've got normal, we've got breaker open, A, B, and C. And we've got each of the values should be associated with a certain value at that certain state. So in a normal situation, we should see the health being false. We should see, let's see, I'm hoping to find some of the currents or there we go. We've got the magnitudes not being 0, but then once the breaker opens, sure enough, the magnitude should drop to 0 there. And you can kind of trace this as you go through the CSV file. So let me go ahead and close this out. And then I can go ahead and right click and do, say, apply state. And it will give you the 4 different states within that CSV file. So you can click normal and then hit apply, and all the values will set to that. You can go to the next one, apply, and you can step through each of these states and have all of these change to be a more logical state for your situation to be in. For example, auto data change possibly could end up in a situation where a breaker would open, but the current's still at 20,000 or something like that. So this is how you can get a more specific view and a more specific state for your simulation. Of course, there is one more way you can do it, and that is through our JavaScript engine. So if you right click and do add, you can do JavaScript. And the JavaScript will allow you to be even more specific. The JavaScript interface here allows you to do everything that you can do using JavaScript. The conditionals, state machines, loops, interrupts, subscriptions and callbacks, everything like that. So it'll allow you to be a little bit more specific. So you could do something like var x equals 0 if you wanted to do a while. So while x is less than 10, put x plus equals x plus 1 or whatnot, and then you can put whatever logic you want in here to do a while loop a few times. But what I like to do is something a little bit more logical. We were talking about a breaker and current before, right? So it could make sense that you want to subscribe tag value. That's how you subscribe to a point, and that point will be a breaker position. So let me go to my XCBR here, and here's the position of the XCBR. I'll copy the path out. And so I'm going to subscribe to this breaker, and anytime this breaker changes, I'm going to call a function called change current. And then after that, I would need to do a function change current, and I think the values here is value, quality, path, timestamp, or something along these lines, right? You can actually, if you're not 100% sure of what these functions do for any of our samples, you can actually come in here and highlight, and then do a right click and do help. And that will search all of our helps, all of our JavaScript objects and functions, and try to find the function subscribe tag value. Let's do it like that. And then we'll come in here and do help. And it will search through, and it will try to find the subscribe tag value functionality here. And sure enough, here it is. And then click OK. And it will take you directly to that. Now, we have obviously support everything that JavaScript does innately, but we have created a whole library of functionality inside of DTM. And those aren't you're going to be able to find any support or anything online for. So we've provided this help JavaScript objects and functions. And sure enough, here's subscribe tag value, allowing you to do a callback whenever it changes. And I did have it backwards. It is path value and timestamp. So, something like this. But the idea here would be is once you have this function, you can say if value equals on or true or whatnot you need. So if the breaker is open, then set tag value path to current to 0. And then you can do like a else set tag value path to current equals 232. Obviously, you can tell I'm just kind of pseudocoding here to give you a basic idea of how this would work. But basically, anytime that this breaker position changes, change current is called. The function change current is defined as such. That will allow you to make it so anytime for any reason, another script, data changes, auto data changes, CSV files, whatever, it'll go ahead and set the path of this. Now, in JavaScript, this will just immediately end. So you need to basically set up a while forever loop. So while 1, that way the script won't end and the value changing will be caught at any time. And then you'll want something called process script events, which is basically a fancy wait that allows you to just sit there in that forever, not consuming all of your cycles, but it is basically waiting for that data change to happen at any point. So those are the top 4 different ways that you can change data inside of a server. All of this has been for 61850, but also applies to DNP3, 101, 104, Modbus, all the other protocols as well.